Now, if you look at the second example, it's 2x plus 3 is less than 11. Here, x belongs to whole numbers. It's the same. I have used the same in equation. The only thing that I have changed is here x belongs to natural numbers. In the other one, I have used this as whole numbers. Okay. So, solution should be the same. Whether this belongs to natural numbers or whole numbers or integers or real numbers, this solution will be the same. Okay, because I am not changing this. Okay. So, look at the second one. The second one is 2x plus 3 is less than 11. But now x belongs to whole numbers. So the solution in the previous case was, after solving the two steps, you get x is less than 4. Now x is less than 4 and x belongs to whole numbers. So you are going to look for whole numbers which are less than 4. Okay. So which are the whole numbers which are less than 4? Are 0, 1, 2 and 3. It's less than 4, therefore 3, then 2, 1 and 0, because whole numbers start from 0. Okay. So I have written the solution set as x is equal to, as a set, 0, 1, 2, 3 are the values of x. Now the same solution can also be represented on a number line. Okay. So draw the number line with the arrows on both sides. And these values should be there on your number line. You can put one extra value on both sides. Okay. There is a 0 here, so I am putting one extra value on the negative side, -1. And there is a 3 here, so I put one extra value on the positive side, that's 4. Okay. And then to represent this solution, 4 values are there. So put a shaded dot over 0, shaded dot over 1, shaded dot over 2 and over 3. That's the solution on the number line. Okay. This is for x belonging to whole numbers. Next one is the same example. 2x plus 3 is less than 11, but x now belongs to integers. Solution is the same. X is less than 4. Now, x is less than 4 and x should belong to integers. So you are looking for integers which are less than 4. Integers which are less than 4 are 3, the next integer immediately after 4, which is less than 4, is 3, then you have 2, 1, 0. Now, because it is an integer, you also have negative values. Okay. So, after 0 is -1, -2, -3, -4. I have not written everything, so I have put dots and close the bracket. Okay. So, the solution here, x is equal to, actually it starts with dots, which means it is coming from infinity, all negative values, and I have put few of these negative values here, -2, -1 and 0, then comes the positive values 1, 2 up to 3 because it is less than 4. Okay, that's for integers. Now the same solution also can be represented on a number line. Again the number line is same. You have arrows on both sides and you see there are few values which are here, you can mark those. Okay. And if you want, you can put some extra values. Okay. So I got 3, 2, 1, 0, I put few extra values, -1, -2, -3, -4. Okay. The arrow represents that it goes up to infinity. Here also, after 3 I put one extra value, that's 4, and the arrow represents that it goes to infinity. Okay. Now to represent these values on the number line, you have a 3, so a shaded dot over 3, then 2, 1, 0, -1, -2, -3, -4 are also there up to infinity. Okay, so you have -2, -3, -4, and then it continues. Because it continues, I have put continuous dots after -4 and put an arrow, showing that it goes up to infinity on the negative side. So that's the solution for x belonging to integers. Next, the same in equation, but now x belongs to real numbers. Okay. Now, natural numbers, whole numbers and integers, all three can be represented on a number line and also as a set. But for real numbers, you cannot represent this as a set. Let's say if I have an example, x is less than 2. So I cannot I cannot write this as a set saying that x is less than 2 means 1, 0, minus 1, minus 2, because there are all possible decimals between 2 and 1 and 1 and 0 and so on. So everything cannot be represented as a set. So we do not represent this as a set, we represent this on a number line. Let's see this. By solving this you will get x is less than 4. But now x belongs to real numbers. Okay. So as I said, you cannot represent this as a set. So you represent this on a number line. So I have drawn the number line with arrows on both sides, and if you look at the value here, it's positive 4. So there is a positive 4 and I put an extra positive value, that is 5. And I have also included few values below 4. Okay. That's 3, 2, 1, and I have also put few negative values. Okay. Read this again. It says x is less than 4. It is not x is less than or equal to 4. It is not equal to 4. Okay. If it is not equal to 4, then 4 is not present on your number line. So what we do is, above this 4, you put a hollow dot. A shaded dot means that value is present. Okay. Here, it is not equal to 4, therefore 4 is not there, therefore you put a hollow dot over 4, showing that that value is not present. So I put a hollow dot over 4. Now read this again. It says x is less than 4. On the number line, you have to know which is the less than side and the greater than side. Okay. If you go towards your left, it's less. If you go towards your right, it is more, greater. Okay. So here it says x is less than 4. So I've already put a hollow dot over 4, and because it says it is less than 4, all values are on the left side of the number line. So less than 4. These are the values. You don't put dots over each one because there are many decimals between each of these numbers which are represented. Okay. All real numbers. Therefore, we use a line. Okay. Line showing that it is less than 4 and it goes to infinity. Okay. That is for x belonging to real numbers and x is less than 4. Okay. The same sort of example, I have changed something little bit. 2x plus 3, this was less than, I have made this less than equal to. Okay. It's less than or equal to 11, and x belongs to real numbers. Almost everything is same except for the sign which is here. This was less than, this is less than or equal to. Okay. If you solve this, it's similar to this, x is less than or equal to 4, and x belongs to real numbers. Again, it belongs to real numbers, therefore we cannot write this as a set. The only possible way it can be represented is on a number line. So draw the number line, same way. Draw the number line with arrows on both sides. Mark all these values which are required. Now read this. In this case it was x is less than 4, no equal to sign was there. But here x is less than or equal to 4. Here x is equal to 4, therefore on top of the 4, you put a shaded dot. Here equal to was not there, so I put a hollow dot. Here equal to sign is there, therefore I put a shaded dot, which means it is present. Okay. And if you read further, it says x is equal to 4, shaded dot. X is less than 4. Less than 4 means it is in the left side. Okay. All values are on your left. So I put a line going up to infinity. Less than 4, all the numbers which belong to real numbers. Okay. Next. Same example, again I have changed this sign. Now it is 2x plus 3 is greater than 11 and x belongs to real numbers. This sign has changed, it's greater than 11. Okay. If you solve this, you get x is greater than 4. Now to represent this on the number line. Same sort of number line I have drawn. Okay. If you read this, x is greater than 4. It's not equal to 4. So above 4, I have put a hollow dot. If you read this, it is greater than 4. Greater than means on the right side of your number line. So from 4, you just draw a line going up to infinity. In the previous case, it was x is less than 4, therefore the line was on the left side. Here it is greater than 4, therefore the line is on the right side. Okay. Slight change. This was greater than, now it's become greater than or equal to. Solution is x is greater than or equal to 4. X belongs to real numbers. If you read this, x is equal to 4. Therefore, I put a shaded dot over 4. X is greater than 4. Therefore, it should be on the right side. So, draw a line on the right side and put an arrow. Okay. This is all about real numbers with particular signs.